At the beginning of the Myrtle story there is a rainforest, one far older and more vast than any that still stand today, Gondwana. Today her chapters are spread out across the southern hemisphere, with Southeast Asia and South America being host to the fleshy-fruited Myrtaceae and Myrtaceae tribes, and Oceania to the rest of the Myrtoideae subfamily. The question of where and when exactly Myrtaceae originated is a muddy one, as the fossil record for any organism is far from complete and often fragmentary across continents. For plants to be fossilized, a Lagerstätte is often required, which are marine or lacustrine sediment deposits of exceptional preservation. These sites are rare, which throws questions as to whether organisms truly originated from where and when they are fossilized, or if that's all we have left of wider ranges. In paleobotany, we fill in the gaps as best we can using microscopic pollen morphology and macrofossils, which can be present as leaves, stems, wood, charcoal, roots, flowers, cones, catkins, fruits, and seeds, all of which could be described as separate species in the absence of a complete specimen. We name these parts based on their modern equivalent, with suffixes to indicate the part of the plant, as in phyll for leaves, or to link them to likely relatives, as in idites. From pollen preserved as grit in sediments, and flowers as shadows on stone, we know that flowering plants had evolved by the Cretaceous, so the most basal of Myrtaceae ancestors likely also had their heyday then. The earliest fossils we do have are Myrtaceae pollen records from Gabon, Borneo, China, Argentina and southern Australia, all in the late Cretaceous around 60 million years ago. As time moved into the Paleogene, the progenitors of modern groups begin to appear, including primordial eucalypts in the humid jungles of the Eocene, whose fruits and flowers allow us to place them on evolutionary branches together with their extant cousins. From the shapes and the sizes of the leaves we find, we can estimate the climatic conditions they grew in, and so reconstruct entire ecosystems, which is important because this was a time of massive climatic change, with the Paleocene-Eocene transition marked by a rapid 6-degree spike in global temperatures, and the Eocene-Oligocene transition following with the Cenozoic's largest cooling event. While these shifts were happening, the continents themselves were drifting apart. From the Cretaceous to now, Australia moved from the pole towards our current position, shedding our sisters Antarctica, Papua New Guinea and Aotearoa, New Zealand. Our inland seas reformed and dried multiple times, and our coastline waxed and waned with sea level changes, which in their own turn affect the weather and climate we receive. Eventually, Australia was isolated, and starting on a much harsher and drier track. All this upheaval left the ancestral members of Myrtaceae with a choice: radiate quickly into new niches, or remain in ever-decreasing refugia. Surviving in the drier forests and grasslands of a post-Miocene world took ingenuity and iteration. Myrtaceae opting to radiate into these new conditions had to develop harder leaves, termed sclerophylls, which are regarded to withstand water loss, low nutrient zones, and the harshness of the sun. Some also developed silver foliage, or reduced their leaves to microphylls, as other families do to cope with similar environmental pressures. Both wet and dry sclerophyll forests are marked by their susceptibility and adaptations to wildfires, and are today's archetypal Australian landscape. Dry adapted Myrtaceae tend to dominate these forests, often sheltering rainforest cousins in dense wet understory, or paperbarks and tea trees in the more open grassy understory of dry forests. Aside from having hard and thick leaves, even early eucalypts show evidence of having epicormic buds, axial meristems dormant in the trunk and branches, from which plants can reshoot quickly after a fire. In fact, many species rely on fire to open their woody fruits and signal to dormant seeds that the competition has been eliminated and they can germinate in the understory safely. The world's tallest flowering plant, Eucalyptus regnans, is one of these. But not all evolution is devoted to workshopping new ventures. Staying put and specializing is also a fruitful business. For those who stayed in rainforest refugia, their crucial adaptation to the live fast, die smart lifestyle is the fleshy fruits of the Myrtaceae tribe, whose investment in being oh so tasty encouraged close relationships with animals to disperse their seeds through their rainforest homes. They evolved over millions of years side by side with unique fauna to form intricate partnerships, including a rather strange hairless primate, which now ships their descendants all over the globe in record time. This primate species, over millennia, has been shaping Myrtaceae into a myriad of new forms for their foods and gardens, creating crosses and dwarfs and new formers. Unfortunately, we're also causing problems and seeing the act of evolutionary pressure accelerated in those susceptible to myrtle rust, a fungus which evolved far away from Australia and has no natural checks or balances here. Many of our most specialized species are now endangered or extinct, with brutal consequences for the ecosystems they support. Populations are becoming isolated, which could lead to extinction or speciation depending on how well we handle this crisis. The continued existence of Myrtaceae is now up to us. Whether they're as noticeable as the gum trees and cloves or as little known as scrub turpentine, their presence and evolution are just as important as our own. This program was recorded on Bunurong land. All references can be found in the podcast description.